In December 2015, OpenAI launched as a pure nonprofit research lab. The organization was explicitly structured to be insulated from market pressures, operating with a charter strictly isolated from financial incentives. By March 2026, OpenAI operated as a megacorporation, commanding an $840 billion valuation. It controlled sprawling infrastructure spanning multiple continents. Overseeing this decade-long structural metamorphosis was Sam Altman. Under his executive tenure, the laboratory completely rebuilt its own foundational rules to survive. A mathematical property of artificial intelligence forced the pivot away from the original nonprofit model. It was an engineering necessity rather than a spontaneous shift in business philosophy. OpenAI's corporate history serves as a direct, lagging indicator of the physical compute required to build machine intelligence. The business structure evolved only when the engineering required it to. The catalyst for this structural breakdown arrived in January 2020 with the publication of a research paper titled Scaling Laws for Neural Language Models. This graph plots the paper's core finding. The error rate, or loss, of a neural network predictably drops as you increase the amount of compute used to train it. The relationship is a strict, downward-sloping power law curve. Following this curve into the future revealed a difficult truth. Continuing to lower the error rate and increase intelligence would require exponentially more hardware, eclipsing the financial limits of a standard nonprofit budget. To chase the frontier of AI capabilities, OpenAI had to abandon smaller, compute-efficient reinforcement learning projects, like their game-playing AI, OpenAI 5. OpenAI 5 required about 770 petflops of compute for its training run. Petflops, or peta floating point operations per second, is a metric used to measure the processing speed of high-performance computers. Moving to natural language pre-training would demand orders of magnitude more power. The scaling laws turned artificial intelligence research from a clever software puzzle into a massive, capital-intensive hardware race. A charity could not buy enough silicon to stay in that race. The technical shift toward massive pre-trained language models accelerated as the lab moved from GPT-2 to GPT-3. GPT-3 achieved few-shot generalization entirely through the brute force of scaling up parameters. Few-shot generalization is a model's ability to accurately perform a new task after being shown only a handful of examples. This flowchart illustrates the organizational rupture caused by GPT-3's compute demands. In March 2019, the organization created OpenAI LP to sit beneath the original nonprofit board. This new entity utilized a capped profit mechanism. It was a hybrid legal structure designed specifically to attract billions of dollars in outside investment while technically preserving the oversight of the original charter. The immediate result of this corporate restructuring was a July 2019 partnership. Microsoft invested $1 billion and became OpenAI's exclusive cloud provider. By May 2020, Microsoft built a bespoke Azure supercomputer for OpenAI. It featured over 285,000 CPU cores and 10,000 GPUs linked with massive bandwidth. This massive physical asset became the anchor for all future foundation models. Without it, the subsequent generations of AI simply could not have been trained. The capped profit structure operated exactly as it was engineered, as a massive financial absorption mechanism, specifically designed to ingest the capital needed for the compute demands of the GPT series. Raw pre-training scaling produced highly capable systems, but their outputs were often unpredictable and difficult for average people to use safely. The lab needed a steering mechanism. In January 2022, OpenAI introduced the InstructGPT methodology, utilizing a concept called reinforcement learning from human feedback, or RLHF. RLHF is a training technique where human ratings are used to score and shape the final outputs of an AI model. The roots of RLHF trace back to the lab's preference-based reinforcement learning research in 2017. It was a long-term strategy finally deployed to force raw language models into alignment with specific human instructions. Applying this strict alignment mechanism to a conversational dialogue format resulted in the explosive November 2022 launch of ChatGPT. With the launch of ChatGPT, OpenAI shifted into a high-volume developer platform, moving from the publication of research artifacts to the continuous management of live inference. The sheer volume of users interacting with this platform forced a massive expansion of the Microsoft partnership in January 2023. The lab required a multi-billion-dollar investment to transition their Azure infrastructure from A100 to H100 GPUs, strictly to keep up with live user prompts. GPUs, or graphics processing units, are specialized silicon chips designed to accelerate the mathematical calculations required for artificial intelligence. The immense pressure of scaling an enterprise platform exposed severe fractures within the hybrid corporate structure. The nonprofit board clashed with the operational reality of the business, culminating in the November 2023 leadership crisis. To stabilize the company for global enterprise scale, the board was reconstituted. Heavyweight economic figures like former Treasury Secretary Larry Summers were brought in to establish traditional corporate governance maturity. Productizing the technology created an inescapable compounding loop. Consumer adoption demanded massive real-time inference compute, and maintaining that compute required vast capital formation to sustain the servers. From late 2024 to early 2026, the technical frontier shifted again, moving away from simple chatbots toward autonomous, long-running agentic systems. Building an AI agent requires converging three research threads: massive pre-training, strict RLHF alignment, and deterministic software tool use. A critical layer arrived in June 2023 with JSON function calling, a standard text format allowing the language model to convert abstract text into executable software commands. In September 2024, OpenAI launched the O1 reasoning series. These models were trained via reinforcement learning to spend more time thinking, iterating, and error-checking before providing an answer. This approach introduced the concept of inference time compute. By forcing the model to think longer on every prompt, the massive energy costs of AI shifted away from the initial training phase and directly onto the active user session. This evolution directly enabled the January 2025 Operator release. Operator featured a computer-using agent capable of reading screens and manipulating standard graphical user interfaces completely on its own. To achieve this, the architecture integrated multimodal vision deeply into the model's core. Vision functioned as an internal reasoning substrate, where the agent could actively process visual data while making decisions, rather than acting as a simple input mechanism. Achieving true autonomy required an architectural overhaul that drastically amplified the real-time energy and hardware cost of every single action the model took. By early 2026, the operational reality of training multimodal, continuous reasoning models like GPT-5.4 finally breached the physical limits of a single cloud provider. In October 2025, OpenAI executed a final corporate restructuring, completely eliminating the complex capped profit LP model that had governed them since 2019. This organizational chart shows the new, streamlined reality: a standard public benefit corporation overseen by a reconstituted nonprofit foundation holding special governance rights. This structural simplification was mandatory to absorb the next phase of investment, a massive $110 billion funding round announced in late February 2026. Concurrently, the October 2025 agreement revision explicitly removed Microsoft's right as the exclusive compute provider, freeing the lab to execute a multi-provider hardware strategy. This massive capital formation and structural freedom had a single ultimate destination: the Stargate project. This map illustrates the sheer geographic footprint of Stargate. It is a $500 billion, 4-year AI infrastructure build-out designed to network massive compute clusters across the United States. This physical mega-infrastructure was the inescapable endpoint mathematically predicted by the original scaling laws paper published 6 years earlier. To lower the error rate, you must build the machine. OpenAI's trajectory proves that reaching the frontier of artificial intelligence requires the most capital-intensive physical infrastructure ever constructed for a single computing project.